practice transforming the equation of a parabola in general form into its standard form. Now, this is the general form of a conic section, not specifically a parabola, but if either A were 0 or C were 0, we would have a parabola. So let me write that down. A equals 0 or C equals 0, but not both. If they were both equal to 0, we would not have a parabola. But we're going to transform an equation that looks like this into its very useful standard form. And from standard form, you can see lots of the important pieces about the parabola. So let's jump in and do a problem. And we'll do this one. So our goal first is to write the equation in standard form. Again, it will look like this or like this. Notice in this problem, we have y squared. So we know our equation is going to look like this. We want a perfect square on the left-hand side, and it's going to be with respect to y. So let's do that. So here, I want to keep the terms that contain the y's on the left-hand side. So I'll have y squared minus 10y. And my 12x and my 37 are just in the way on the left-hand side, so I'm going to subtract them, and they'll move to the right-hand side then. So I have a negative 12x and a minus 37 on the right. But now I'm going to complete the square. Remember, we take half of the coefficient of y, so that would be negative 5, and square it. That's positive 25, so I need to add 25 here on the left. And that means I need to add 25 on the right as well. And the whole goal is to get this to be written as a perfect square. So we have y minus 5 squared on the left-hand side and negative 12x, let's see, minus 12 on the right-hand side. Now, just one more thing. Let me bring back the standard form. We want the coefficient of the linear term to be factored out. So we'll factor out negative 12. So we have y minus 5 squared equals negative 12 times x plus 1. And we have it done. This is the equation in standard form. Now, the nice thing about standard form is so much of the parabola is accessible to us. We can see the vertex and easily find the focus and directrix and graph. In fact, to finish, let's just do that. I rewrote the equation right here. The coordinates of the vertex are just looking at us. The x-coordinate of the vertex is here and the y-coordinate is there. So let's just jot that down. Vertex, negative 1, right? The opposite of this value here, positive 5. Now, I'm going to sketch this over here. It'll help me find the rest of the pieces with my vertex at negative 1, 5. I'll put 5 about right there. And I recognize that this is an x equals y squared type, so it opens right or left. But I can see the p is going to be negative, so this is going to be a parabola that opens left. I'm just going to lightly draw that in so I remember that, because we know the focus now will be inside the parabola and the directrix will be on the opposite side. So let's find P so we can find the focus and directrix. We set 4P equal to the coefficient of the linear term, so 4P equals negative 12. So that gives us P equals negative 3. So from this point, I move left 3 units. So 1, 2, 3. I'll be over here at negative 4. So here's my focus right here. I was at negative 1, 5, and now I'll be at negative 4, 5. Let's write that down. And I travel 3 units the other direction to find the directrix. So I'm here at negative 1. I'm going to move right 3. Let me use a different color here. -1, I'm over 1, 2, 3. So I'm over here at 2. Started at -1 and I went right 3. So my directrix would be right here. Remember, the directrix is a line, so take care when you identify the directrix that you write the equation of a line. So this is a vertical line, so it will be x equals 2. And last, I want a respectable graph. I know it opens to the left, but I'm not sure how wide or narrow it will be until I use this number. Remember, the absolute value of 4p, in other words, the absolute value of this number right here is the focal diameter. That's the distance across the parabola through the focus. So I know the focal diameter, the distance across the parabola through this focus, will be 12 units. That means up 6 and down 6. So let's draw that in. I'm here at 5. If I go up 6 units, I'll be at 11. Let's ballpark that about right here. So from here, when I go up 6 units, I would be about right there. Similarly, I would go down 6 units and I would be down here at -1. So my parabola is going to go through those 2 points. Should be symmetric right across this line. There's my axis of symmetry right here. And I have my parabola drawn. Well, it doesn't look too beautiful over here. I should have made it a little smoother. Sorry about that. But here's my parabola. And this is part of the beauty of the equation in standard form. The vertex is looking at you, and the focus and directrix are easy to find. And you can even see how wide or narrow the parabola is.